Hello everybody, Hardcore Ninja here with another SFML side-scroller game engine tutorial. Alright, so in the last video, we got a little bit of a tile map going. Alright, so we created all of this. And before we get going, I think I want to just put a wall here, just to kind of really specify that that's the beginning of the level. So I'm going to do that, but essentially the goal for today is to create the entity and player class, alright? But first, let me just do this one thing. I'm going to go with the tile map. I'm going to go into here, and what I'm going to do is I'm just going to re-enable my color codes so I can see. Beautiful. Go into the editor here, and let me see what we got. So I think I'd want... So I'm going to have to take this little corner here, like that. I'm going to have to hit T, so I'm on a wall. I'm going to have to rotate this like that, place that right there. Great. And then take this, but rotate it like that. Okay. Just like that. And then cancel there, grab another one of these. Okay, we'll have to rotate it like that. Okay, oops, I gotta put this on layer 1 because it's some information there. All right, cool. And rotate this back around here like that. Beautiful. Go back to layer 0. And I see here, I didn't have wall enabled for this, so that's good. All right, now you see I have some lines here, so you get the little one here and try this. I'll put this on layer 1. Nah, I don't see that helping, so I'm going to delete all of that. Throw it one more. Oops, no. What's going on? Okay, there we go. Ooh. Nah. There we go. That's working. Nice. I cleaned it right up. All right, that didn't work. So let me just try to I can cover it. Oh no, maybe I gotta. No, that didn't cover it. Just make sure all that's cleaned up. Go back to 1. Any extra information here? Okay, cool. So that's fine. Go back here. I know one of these will clean it up. There we go. That's cleaning it up. Not quite. Let's clean that up. How did that not clean that up? Let me see. Maybe if I get them smaller? No. Clean all that up, because I don't think that's helping. Let me try one more thing. I feel like that's gonna really... Nah, I don't want that. I know I can clean this up with something. Let me see. Just trying to hide that. There we go. Got it. There we go. Now that should look pretty decent. All right, this got knocked out. Okay, that should be good. Right, so save, quit game. Then essentially undo this. All right. Go to side scroller. Oops, that's not it. This. Go to config. Copy this. Delete this. Just make this one level 1. Okay. So now, great. You see, now we got that nice wall there to indicate the start. All right, we're ready to get going. We are ready to get going. Let's do this. Okay, so the first thing we're going to do is we're going to create the base entity class. So we've got to add class, call this entity, and entities are going to be the player, the enemy. It can also be objects like items. Essentially, anything you interact with in the game is going to be the entity. Okay. Everything we just did before was related to just building it's kind of the hardest part about it, actually, just building the engine, the design, custom levels, interesting levels, and that's what we did. All right, we're done with that. That's actually the hardest part of this. So yeah, we're going to be moving forward. So entity.h, entity.cpp. All right, so let's just make this cross-platform. Entity, and then define, and then just copy this baby again, and then end it. All right, cool. Right, so we got private. Private. No, I'm sorry. We do not have private. We have protected. If we have any initializers, we can make those private, but you need to make it protected. So again, protected is kind of in the middle between it's in the middle between private and, I'm sorry, there's some music going on my ear that's really annoying. I have to change this. I'm sorry. I have to listen to something, but just not this. Let's just keep it to the. It's like elevator music, but like with rhythm, so it's not too distracting. Okay, yeah, so protected is in the middle between private and public, and essentially protected allows classes that inherit this base class to see the member variables we deem quote-unquote protected, but not classes outside of inheritance. So it's great for inheritance, that's essentially it. I heard that some academia is like, oh, you shouldn't use protected. Well, I don't know. I don't know what to say about those people. All right, so here we go. So in here, we just want to put variables, anything that more than one entity will need. All right, so essentially, if you have something that's super specific to the player, then keep it on the player. If it's something like the generic sprite or sprite rec, and you know that all entities will need it, just throw it in here. Okay, so we'll need SF rectangle shape, and this will be the sprite rec. All right, that's going to be like the collision rec. We'll have sprite, which will actually be the sprite itself. SF texture, this will be the sprite texture. And SF int rec will be the sprite int rec. Okay, beautiful. So these are kind of like generically our sprite variables. All right. Then we will need, if you go into the base class header, we will need the keybinds. Like that. Call this again keybinds. Okay. And I think that will be it for now. Oh, well, we can put the movement variables in. Like items may not move, but it's still okay to put them in here because you'll need these movement variables for both the player and the enemy. So you don't have to use all the variables in here, but you should just have them in here just so you don't have to repeat yourself. So we'll call these movement variables. All right, so we'll have float max velocity. We'll have SF vector 2F and call that velocity. And we'll have float acceleration, float deceleration. And let me just throw these into Google and make sure I'm not stupid. Yeah, acceleration, I spelled it correctly. Good job. All right, how about deceleration? All right, great. Spelled it correctly. Nice. All right, fantastic. So this is good for now. Now we can go ahead and make some um, pure virtual functions that we'll definitely need. So like obviously like the update function, const float et 0, and then virtual void render const float et. What's that? Okay. Let's update functions, and then call this render functions. Cool. Just like that. And we'll go ahead and I guess throw the class 4 declarations for what we have right now. So might as well just do class entity in case we have any enums or struts that require reference to it, I guess. Just for scoping, essentially. But the other stuff, class SF rectangle shape, class SF sprite, class SF oops, come on, texture, class, ooh, this render is supposed to be SF render target reference target. Okay, so class SF render target, like that. Okay, beautiful. Excelente. All right, so that is good, and we can put the entity into our base classes right here, just like that. Bada boom, bada bing. This is not a class, that's a type. All right, cool. All right, so we're just gonna save that, and just open the base class. I like to see everything here just to make sure I'm not messing up anything else other than what I'm working with. All right, fantastic. So we can go ahead and close that down. I think that's all we'll need for now. Then we're going to go to project. Actually, I'll go over here, go source, add filter, call this player. Okay. Now we'll go to project, class player, and player will have the base class called entity. Okay, awesome. Right, so I'll just drag these, put them under player here. Just like that, fantastic. We'll go ahead and make this cross-platform. Okay, sweet. All right, so private, public, oops, public, that. All right, so the player will take in an unsigned tile size. It will also take in the support keys. Take in this. Spell this. Okay. And I think that's all we need for right now. Okay, so cool. And then we'll have virtual player structure. Of course, we can go ahead and grab initializers. We'll definitely have a few of those. Structures, destructors, put that right here. Have the update functions there. I will have the render function go right there. Okay, cool. Nice. All right, so this void update float. No, what's the concept? Float dt. That's the pure virtual we'll need. And then of course void render sf render target reference target. Right? Cool. Got those in there so we don't get any issues. All right, so for initialize, we'll have void init variables, of course. Always need that. And then we'll have void init keybinds. Okay. And then we'll have void init sprite rect. And then we'll have void init sprite. Okay, so essentially we're going to be moving around the sprite rec, and then the sprite is going to update its position relative to that. And I think that makes the most sense. You could probably do it the other way around. Remove the sprite rec moves around to it. But it makes sense to me that you're moving the sprite rec because that's handling all the collisions. So I think I'd want to move that first. And then at least that's how it works in my head. Okay, so right. So we'll call this so we'll need the unsigned tile size. And actually so let's go back for a second. So what we'll do is we'll create a enum class called animation state. Okay, and let's take a moment to I'll delete this. I was just experimenting with that earlier. So desktop. Well, I'll make that from scratch. So go over here and go into resources, go into images, and we don't actually have anything yet. Okay, so if we go to the desktop here, we go to here, and we go to the hero sprites, we have this. All right, so we have this sprite sheet here, and I did some experimentation with this, and just like the tile map, these aren't perfect. Okay, so the guy claims that they're 16 by 16. He tried his best to make them 16 by 16, but you will end up with like the foot of the top one here if you do exactly 16 by 16 or whatever. So the first thing we're going to want to do is we're going to want to go to that resize app and blow this baby up. This is way too small. Excuse me. Excuse me. So go to percentage 400 optimized, and then we're going to save this baby as. All right, cool. I have this stuff. Oh yeah, let's go ahead and save that. So we'll call this generically the sprite sheet. So cool, like that. And we'll go to desktop, go to side scroller, go here, go to references, go to images, and we'll make a new folder, player. And in player, we will paste this. Okay, awesome. Fantastic. All right, so we got that in there. All right, so we got the tile size. Cool. Okay, so animation state. So if you haven't noticed already, all of these guys are facing to the right. All right, so we'll have to do some voodoo to flip them to the left. Okay, and then so anyway, essentially we have one run animation, and this second one here is the run animation. And then we have the idle animation, which is this one way down here. So this is the idle, and this is the run. I've already played with this a little bit, so that's how I know so quickly. All right. So we have two. I might break this up into different. What am I trying to say? I may break this up into different. What am I trying to say? I might break this up into different, like, move left, move right. But I think for right now we can do idle. Oops. Idle. 0. And just run equals 1. All right, for right now. Okay. And then what I want to do is I want to make a struct called player details. All right. And I also want to go back to the base state here because I know that we will definitely be using this elsewhere. So we're going to make a enum class direction. Okay. And in here, even though this is technically not a direction, I guess we could. All right, so you're either going to be facing left or right, all right? So there's nothing more than that, all right? So we might, even though idle is not technically a direction, we may have to add it, but let's see if we can get away with that. So left equals 0, right equals 1, okay? And I put this up here because this is going to be, yeah, that's going to be specific to this. Now, I actually may make this even more specific just to make sure that there's no naming errors and call this player animation state. All right, so in player details, we will have a direction called, guess what? We'll call it direction. And then we'll have a player animation state called, guess what? Player animation state. And then we will have, you know what? I think we just keep an animation state. I think we can keep an animation state. It may, but you know what? If we have the header of like the enemy, now you have to keep it player animation state just to avoid, just to make sure you don't have any. Because if you just call it generically animation state, then you have generically animation state on the enemy, and both of those headers are added. These are in the global space, so you'll be like, do you want the one from the enemy or do you want the one from the player? So just make it specific. So we got direction. All right. Okay. Cool. And I think that's all. That's all we need for this moment in the struct. But we will add more to this. Like we'll add like the hit points, HP, etc. Tile size can live out here because we type it so much that that'd be really annoying if it was in there. And we're just kind of generically pulling this in from the outside. All right, so here we go. So we're going to start with the init variables. And so we'll do this play. Oh, I forgot to do this. All right, so you need to do here player details, player details. You need to make a, so essentially you're making a member variable of player details. So player details dot direction equals direction right. Okay. By default. And then this player details dot player animation state equals player animation state idle by default. Okay. Cool. Yeah, this is definitely going to be sick. Alrighty. And then if you go into entity here, we have max velocity, velocity, acceleration, blah, blah, blah. I'm just going to check my other project because I had good values and I don't want to go through that whole experimentation process again. So, yeah. Just going to open this up. and we will go to layer. And just see what we had. Oh, no. It's going to new player. Date buttons. Okay, so we had velocity, max velocity. Okay, so yeah. So this max velocity is going to be equal to 1024. Is that what we had here? Data. We had here. Yeah. And then, of course, velocity by default. This velocity is going to be equal to SF vector 2F. So the 2F is for the X and the Y direction, obviously. And then this acceleration is going to be equal to, so these values are really big because we're multiplying by dt. So that's why they seem ginormous. Deceleration will be equal to 19. Okay, beautiful. Okay, there we go, there we go, there we go. So there's some all of that. Cool. And I'll leave that open just in case I need to look at it, but we'll keep that like that for now. All right, the keybinds, excellent, will be, you just go to anywhere like main menu, keybinds, and just copy that sucker. Player, just like that. Now, yeah. So put this over here. Okay, so we're gonna want to pass this to here as well, like that. And this supported keys is going to replace this right here. Just like that. Oh, and an entity. Let's just make it so keybind. What I call it, keybind map. Keybind map. All right, so let's just copy this. Just use the exact same name. Cool. Just like that. Cool. Now that's all good. Now you need to change this to player. That's what I deleted before, so we could build it all by ourselves. Right, that should be good. That's all good now. Just space. All right, so what we're going to do, close that here. We're going to go to config. We'll go to this. We'll go new file, save as player. Oops. Here. Big, so we got player, big, no, what am I doing? Player keybinds.ini. Okay. All right, so we want to move left, and that's just going to be A, and we want to move right, and that's going to be D. Okay. Just want to save that. Okay. So now you can go back here and go to resource files, configure keybinds, right click, add, and we'll put player. And we will just drag this under player so that we can see this stuff in Visual Studio here easily. Okay, cool. I'm just going to go ahead and save all so I know what I completed. All right, great. Now we're moving on to the initializing the sprite rec here. Okay, fantastic. So, oh, another thing is, yeah, you're going to want to Going to want to pass the tile size to the variables as well. So by this point, we have already initialized the tile size. So tile size will actually be the first thing. This tile size equals tile. Oh, and just to make sure we're following all of our standards, make sure you follow your standards. All right, don't be a lazy bum with crazy ways of doing things differently all over the place, unorthodox practices that no one's accustomed to. All right, your code should, follow the standards you set. Follow the standards you set. Who cares what those standards are? Just follow them. And another thing is like assume other people are going to be reading this. So, break things up into small steps. Even if you can comprehend something in a big long jargon list of crap, that doesn't mean other people can. So break things up into smaller bite-sized chunks. Okay. So now you're done with variables. All right. So now, so this sprite rec dot set size, and because it's size, we got to make the to this because they didn't accommodate that yet. Maybe they have a reason why they did that, so I shouldn't be making too much fun of it. But this should be this tile size and this tile size. But you're going to want to static cast these babies because you need a float. All right. And the reason why I kept it as an unsigned int is because we'll be using these mostly with the int rec that requires that. So that's the reason why. Okay, so there's a few places in these initializers that will be static casting the float, but there's many more places we'll be using it as an unsigned or int. So that's why if you're asking. Right, if you're wondering. Okay, so we got the set size. All right, so now this sprite rec dot set fill color, SF color, transparent rate. And that reminds me, go over here. Let's go ahead and get our 4 decorations in and try to keep up with this as we go. All right, so we got already, well, class entity, obviously. All right, class SF, well, essentially everything from here. All right, so we definitely just want everything from here. And what's wrong with that? I don't know what's wrong with that, but that's fine. Okay, so class entity, sprite render target, obviously. So we just added like a class SF color. So just kind of as you go, try to add things to here. And then this sprite rec dot set outline thickness 1.f. This sprite rec dot set outline color SF color red. Okay, beautiful. Okay, now the position of this sprite rec. So you should be able to run your program now. All right, and then what you want to do is you want to go into the editor. And remember that this is hiding the beginning, so we want to go way over here. All right, so we want to start right here, okay? Right here. So this is perfect because it's like snappy to the it's very snappy. So we're going to put this right here, and we're going to put our cursor right in the center of this. And this is going to be a really good approximation. All right, so we got 97 by 419. 97 by 418, all right? So 97 by, all right, so that's what I had before. So 97 by 418, all right? So that's what we got. I had tried that out before, all right? So right there. And, oh, and by the way, I'm looking at the mouse position view, all right? Mouse position view. So that's 97 by 97 by, all right, now I'm reading like 96, so 96, 14. All right, so that's going to be a decent position, all right? So click out that way so you don't save anything accidentally. All right, so this, oof, not there. This sprite rec dot set position to 90, what was it again? 96 by 418. 96.f by 418 point. All right. Awesome. Okay. So sweet. That's oh, one last thing we forgot to do. We'll set it here. This sprite rec dot set origin to this sprite rec dot get global bounds. And remember, you have to set the size before you set the origin, because if you don't, it's gonna be like, well, what's the, we don't even know the size of the global bounds. All right, so width divided by 2.f. And essentially, this is a float rec, which is just like an int rec, but with floats. All right, it's the exact same thing. And this is like this is like an invisible rectangle that goes around the object, based on the size and maybe some other factors. But yeah, right? I think it's primarily based on the size. Yeah, because essentially, yeah, this is gonna make a. Oh, yeah, there we go. All right. Fantastic. All right, now we're officially done with that. So we're gonna go down here, and now we're gonna initialize the sprite. Okay. So first we'll do if. So our sprite size is going to be determined by our texture, which should be 64. All right. So first we're going to this sprite texture dot load from file resources images layer sprite sheet dot png. Okay, I think that's what we did. Throw, this doesn't load, then we're going to throw error player failed to load sprite sheet dot png. Okay, beautiful. Okay, awesome. Let me just triple check that, just so resources images player, and this is called sprite sheet dot png. Fantastic. And just make sure that sprite rec.png is really big for yeah, so that should be it. Awesome. Okay, cool. That's the one we increased in size. All right, fantastic. So I'm going to close that. I'm going to go over here, and we're here. All right, so cool. So now this sprite dot set texture this sprite texture. Okay, and maybe even before that, this sprite dot set texture rect is going to be this tile size times 0, essentially 0. So I'm just doing this so it's a variable. All right. So tile size times 0. Now the tile top, I want this to be on the idle animation. Okay. So 0, 1, 2, 3, 4, 5. All right. So 0. So the very top is 0. All right. So this is like 0, 0. All right. Then this will be 1, 0, 2, 0. All right. If I was down here, now it's 0, 1, 1, 1, 2, 1, etc. So 0, 1, 2, 3, 4, 5. This is the idle if you're using what I'm using. So that's going to be this tile size times 5. Okay? And remember, so like this is, oh, I got to SF int rec this. Got to put this in an int rec. Int rec. Like these. Okay? Bam. All right. Now, the tile size, I'm going to do, normally, if these were perfect, you would just do the tile size. But these are not perfect. So you got to make it by 1 pixel smaller. Because if you don't, you're going to get a foot. You're going to get the, all right. So in an ideal situation, this guy would have had the tiles spaced out. He would have had these sprites spaced out properly. But essentially, and you can experiment with this by taking the 1 away. Essentially, if you don't have the 1, you'll get the foot from the top one at the very top here. And on this, I think you'll get the arm. So yeah, you're going to have to cut it by 1. But this is a good way to kind of crop it so you can kind of see. You can use the int rec here to crop. And again, just so you really get this. All right, so this is our image, all right? And these are our little sprite animations, right? And they're like, let's say there's an animation for, oops. Say there's an animation for a circle, and the circle is getting progressively bigger, right? So the sprite rec essentially is this, okay? And this would be, this would be the left side of the sprite rec, all right? This would be the top of the sprite rec, okay? So this is the left side of the sprite rec, this is the top side of the sprite rec. Okay, so that's what these first variables are, all right? If you over here, you see rec left is the first one, rec top is the second one, okay? So that's the first thing, all right? Now, the actual size of this, whether it's this small or this small, is determined by the width of the height, and you can make different widths and heights. So you could get a rectangle, you could do it like this, but we're making it a nice square like this. So it's literally like the width and the height of it. Like if it's really big, it's like this, right? So we set this to the size of 1 tile, all right? And at this position, the left side's at 0 and the top's at 0, all right? Now, the left is at 1 and the top is still at 0. Now the left is at 2 and now the top is at 0. And if we had like another layer here, let's just say that this is like the second one, all right? Now, oops, I'll go back here. Now, the left is at 0, but the top is at 1. Now it's at 1, 1. 1 on the left, 1 on the top. Now it's at 2, 1, all right? And then if it was right here, then it would be 0, 2, 1, 2, 2, 2, etc., right? So that's how that works. That's how that works. Okay. All right, so by this point, we know the size of the texture because we have the texture loaded. So you would need to, so before you get essentially the origin of sprite, you need to have the int rec and the texture loaded. All right. Now at this point, you can get sprite.set origin. All right. This sprite.get global bounds width by 2.f. It's going to be the height. Just like that. Okay. Just like that. Awesome. Now the position, this sprite.set position is going to be equal to this sprite rec dot get position. Okay, and sometimes you need to mess with the offset a little bit, but I actually tried this before and I didn't really have to mess with the offset, so hopefully it's still that way. You might have to move it a pixel here, a pixel there over, but for the most part, these sprites work very well like this, and yeah, you're not gonna have any issues. Um, I would set the origin actually probably at the bottom of this. I would, just make it a habit to set the origin as the last thing before setting the position, because I'm not 100% sure, but the outline thickness of the rect could contribute to the global bounds. I'm not 100% sure, but it could. So you're just going to get the most accurate reading, I think, if you set it down. Okay? And if you don't want it, maybe you can set it for it. It just depends on what you're going for. But I think that this should be pretty good. Okay? So that's all we really need to do for that. All right, now here in the player, we need to call these, right? The player constructor here. Okay, and am I filming? Yes, I'm filming. Great. All right, so this init, init variables dot. Let me make this same standard. Right. Cool. Awesome. And I'll be right back. I have to run to the restroom, unfortunately. Okay, everybody, I'm back. I'm ready to continue. All right, so we're going to call init variable right here. That's what we just did. Okay, cool. And then we're obviously going to call this init keybinds, and then put the supported keys in there, and then just call init sprite rec, and this init sprite. All right, nice. All right, that's it. Bada boom, bada bing. Cool. And then so we've got to make our constructor. Cool. Doke. Cool. And then go ahead and just add these guys here. Ooh, what? Ooh, don't do that. Nope. Copy. Put that right there. And then make this as well. This, put this down right here. Beautiful. Okay, cool. So, okay. So, the way we're going to handle movement is we're going to do it in a series of steps. Essentially, we're going to get the user input, all right? And then we're going to set the velocity based on our acceleration variables. And then we're going to have a move function that checks whether we're at the maximum velocity or whatever, and applies the velocity. And then we'll have the final one, which is going to apply the animation. And all these functions are going to call each other kind of in a chain of events, as you'll see. So the first one will be void update user input. All right. And this will take this DT. All these will take DT even if they don't use them, because we're going to be calling, essentially call this function, get to the end of this, call the next function, and they're just going to be, it's just going to be kind of a chain of events that happens, okay? So this will be the first one, okay? So in here, we'll have if SF keyboard is key pressed, SF keyboard key this key map binds at whatchamacallit, move left. Okay. And you do not want the input time here because like you're moving, you don't want to have to wait every whatever seconds for move, right? So if you just hold this key down, you'll just move left. Okay. So the first thing we want to do is, another thing is we're going to need another direction here called old direction. And this will come in handy, as you will see. We may not even need, we might only need one of these. This could be a lot, but it comes in handy. It comes in handy. It really does. Actually, I think for right now, the old direction I think will absolutely be needed with collisions, but we're not there yet, so I think that this is fine. Okay. So this player details dot direction will be equal to direction left. All right, and this player details dot player animation state will be equal to animation no player animation state run. Okay, for right now, that's all we'll need. Open this up so you can see it. Okay, and this should be an else if, because you don't want to be moving left and right at the same time. Move right. Okay. Cool, 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 cool. Okay. Fantastic. Okay. So that's all we're going to do right now, and I want to break this up into small steps so you really understand what's going on here. So that's what we're going to do. So the first thing in this, and so down here in the update function, the only thing we're going to call for this entire movement is this user input, because we will call the other functions from this, as you'll see. Okay. I also want to create one more at the top of this called, well, I guess it actually should be down here because, yeah. All right, so void update sprite position. You could do this like in the update function itself. It might make more sense to, but nah, it's good to do this. All right, and what you want to do is you want to grab this and you want to put this, because what we're actually going to be doing is moving the sprite rec, and this needs to be constantly updating depending upon the sprite rec. So this will be update sprite position. Okay, that's all you need to do there. Beautiful. Great. All right, so that's just like a necessary thing, but the fun stuff with the movement. All right, so now, so you're pressing a key, and then from when you're pressing move left and move right, you're going to be calling this function, but you're going to put in different variables in it, depending on what you're doing. Okay, and I guess, oh, there should be one here called else if you're not pressing, essentially if you're not pressing anything. And I guess we'll continue to add to this as we have different actions like jumping and stuff. So if you're not doing anything, then yeah, that's fine. Just keep the direction like that. All right, then you're going to be playing the idle animation. Okay. Cool. All right. And whatever the direction you had set here, it's going to be whatever you had it set last. We might need the old direction. Let's just see how far we go with this. Oh, and make sure that you have an exclamation point before both of these, meaning you're not pressing move left and you're not pressing move right. All right? Beautiful. That's really, really, really important. Okay. So now we're going to do void update velocity. And we're going to put this in here as well. And in addition to this, we're going to have float dir for I guess we direction x, and then float direction y. Okay, just like that. Okay, cool. So we have this velocity here in the entity. So this is regarding all of this, right? So velocity is a 2f for x and y, all right? So this velocity dot x is equal to this acceleration times this direction. And this velocity dot y is equal to this acceleration times this direction. Okay? Beautiful. And now here in the update function, so we'll do this update velocity. So if you're moving left, then you're going negative. So you do -1 and then 0.f, all right, for the y-axis. Oh yeah, and you need to pass in dt, just like that. And then here you'd be going positive, and then for idle, you'd be going 0 in both. Okay, and that's how it works. So our acceleration, oh, and by the way, you need to be incrementing this. So this is going to be plus equals. So essentially, as you're holding this right button, you're doing 1 times acceleration or -1 times acceleration, and you're just going to keep incrementing and incrementing and incrementing and incrementing that, okay? And the acceleration is going to be, what do we have it up here? We had it, so 26, all right? So as you hold, for example, the right button is going to be 1 times 26 plus 1 times 26 plus 126, and that's going to slowly go up and up and up and up and up and up, okay? Now we're going to have conditions in the next function that prevent it from getting too high based on the maximum velocity. All right, so close all that. So now the next one here is void update movement. All right, and this is going to be this, okay? And now you would call at the end of this, you call this update movement. You see how it's just like a chain of functions. Okay. Now we'll do for left, and we will do for right. Okay. So if you're going left, you're getting increasingly negative. All right. So essentially, if this velocity dot x is less than the negative version, or actually is greater, let's say it's greater because you're going from 0. If it's greater than the negative version of this max velocity, all right, okay, all right, actually, well, I need to check something real fast. It's a little complex. I just want to make sure I'm doing it right the first time here. So position, no, player. Oh no, this is update. Yeah. Oh, okay. Yeah. Oh, all right. All right. So sorry. So this first one here is if the velocity x is less than 0, because we're adding, we're subtracting. All right, so we start at 0 and we're starting to subtract negative. All right, so if it's less than, then we're definitely moving left. All right, and then essentially, if we're greater than, then we're going right. Okay, all right, cool. Now, if this velocity dot x is less than this the negative version, you actually say less than equal to the negative version of this max velocity, then this velocity x will just equal the negative version of this maximum velocity. All right. Otherwise, this velocity dot x, we're going to add the deceleration to bring it back up to 0. Deceleration, okay? And if this velocity dot x becomes greater than or equal to 0, then this velocity dot x will just equal 0. Point f. All right. So essentially, if we're less than 0, that definitely means we're going left. Okay. Now, if we go beyond the negative version of the max velocity, or we're equal to it, we're just going to equal it. All right. At the same, there is always a constant deceleration force. As we're going left, there's always something trying to pull us to go right. Okay. And if the velocity x becomes greater than or equal to 0, then we're just going to equal 0. And that's essentially it. And that's the gist of this. All right. So now you can just copy this and put it here, and do this, and we're going to switch these around. So now we're going right. So we're going positive, because remember, in XFML, new, don't say it. All right, so this is the screen. So if you're going from left to right like that, you're going positive this way. And if you're going from top down, you're going positive on the y-axis. Okay? They do it like that because it's actually easier to make sense of what's going on the screen when you do that. All right, so that's all you do. And now you need to decrement it because now you're going towards the positive version of it, so you need a force trying to pull you back to 0, essentially. All right. And then if you're greater than, or if you become less than or equal to 0, then you're going to equal 0 there. Right. So that's all that is. All right. So that's pretty much the how we're handling movement there. Fantastic. Okay. Now, then you got to do this sprite rec, because we're moving the sprite rec dot move will be this velocity dot x times dt, this velocity dot y times dt, right? And that should do it. I think you might be able to do this velocity times dt. Yeah, and that should do the same thing. That should do the same. So this will multiply the dt times both the y and the x. Leave. And if this doesn't work for anything, this will be the first spot I'll check. See what's going on. All right, cool. So that's it. So now the next step in this chain is to update the animation. All right. So we'll first do that. Okay. So we'll do void update animation. Okay, just like that. Okay, and an entity here can do, we've got movement variables. All right, now we can do animation variables, and we'll do a SF clock, and we'll call this animation clock. Okay. And everything that requires animations will need that, so you can put that in entity. All right, so we're going to go back to here. So now we're going to update the animation. Okay. at the end of the movement. Okay, so now after this, we'll do this, this update animation. All right, cool. So in here, we'll do float. We can do float total time. It's going to be equal to this animation clock dot get time elapsed as seconds. Okay. And then we'll have a float switch time will be equal to, let's say 0.1f, I think it's good. Okay. Now we're going to have a switch in here to change the variables of the int rex depending on the animation, okay, because we need to do that. But first, we'll do int left start. We'll do int left end. We'll do int width. No, I'm sorry. Int top. We'll do int width. We'll do int height. And we'll do int frame size. Okay. So those are just some variables that we'll need. Oh yeah, and you should initialize all of these to 0. What am I doing? Come on. Like that. Okay. Beautiful. Just like that. Initialize all those to 0. Okay. Now make the switch. Okay. And the switch will be based on this player details dot animation state. Okay. And the first case will be player animation state idle. Okay. Oops, not like that. Not that. All right. And we'll put break. And then let's just go ahead and make the other one too. Run. And then we'll do default throw error player invalid switch entry, and then I just like to copy the function right there. Beautiful. And then you can break as well. Okay. Cool. All right. So in idle. All right. So if we look here, okay, so the idle animation is 0. It's always start with 0. 0, 1, 2, 3, 4, 5 on the top. It's going to start on 0 on the left and then go 0, 1, 2, 3. This will be the end of it. Okay. So, yeah. So what we can do is we can do left start equals this tile size times 0. This left end equals tile size times 3. And a quick way to think about this is like for the left end is if you have like, it's always 1 less than the total number of animations, because 0, 1, 2, 3. So I have 4 here, so it's going to be 3. Okay, that's like an easy way to kind of think about it. Okay, now the top, again, just going back. Well, that's a lot of them open. Let me close all those and All right. So 0, 1, 2, 3, 4, 5. So it's going to be 5 down from the top. So top equals this tile size times 5. 5. Okay. And then, you know what? I don't even think I need the width and the height. I don't even need the width and the height. I just need the, if I'm not mistaken, yeah, I don't even need the width and the height. I just need the top, and then the frame size will be equal to this tile size. And I like doing it like this because it just makes it a little bit easier, makes it a little bit more variable. All right, so that's why. All right, cool. Now for the run animation, we actually have more frames for the left, right? So we have 0, 1, 2, 3, 4, 5, and there's 1, 2, 3, 4, 5, 6 of these, so you know it's going to be 5. So I'm actually going to put 5, and from the top, it's actually just going to be 1, okay? Because look here, 0, 1. All right, this is the run animation. All right, second one. And I found out which ones were what. If you just go into the file pack here, go to hero elements. He has them all individually in case you need them. But if you go down to like run, you see here it is individually as a strip. And then if you look at this, it's you know, it's clearly this one here. Okay. And he also shows you what it should look like. Okay. Awesome. Fantastic. So remember we're setting this when we press the move button up here. So we're setting this here. Okay. And in the variables we have it idle by default. So that's all nice. Okay, so let's go back down to let's go back down here. Okay, cool. All right. So now what we're going to do, we're done with this. Now what we're going to do is we're going to use the total time and the switch time, and you can experiment with the switch time, but I think that this is a pretty good number. So essentially, if total time is greater than or yeah, if it's greater than or equal to switch time, okay. So the first thing we want to do is we want to go this sprite intrect dot top equals top, and this is the top that we set in the switch here. All right. So if it's the idle animation, it's going to be on the 5th row. And 1 second, my wife is screaming. I think she found a bug. I'll be right back. 1 second. Hello, I'm back. Sorry about that. Yeah, we live in spider country, and a big spider just bothered my wife. She screamed, and I had to go kill her. Okay, moving on. Okay, so we're back here. Okay, so we have the switch time. All right, so essentially, and we'll be resetting this time so as it goes through here like this. Okay. So the first thing you want to do is you want to set the sprite intrect to the top. Okay. Now, if this sprite intrect dot left is equal, no, it's all right. This is a big deal. It's greater than or equal to this the left end here. Okay, it has to be greater than or equal to, because I was playing with this before and I was having a big headache because it was equal, and yeah, it's you got to do it like that. I forgot specifically the reason why, but I was spending hours debugging, like I was losing the animation stuff. So to make sure that's greater than or equal to, okay, then this sprite intrect dot left equals the left start again. Okay. Right. Cool. Else, what we're going to do is we're going to do this sprite intrect dot left is going to be incremented by the frame size. Okay. Then this sprite dot set texture rec, this sprite int rec, and then this this animation clock dot restart. Okay. So let me break this down for you. Okay. And that's it as far as our animation loop. Okay. So essentially what we do is, all right, so the total time is greater than or equal to the switch time. Good. Now we can enter this. Okay. So the sprite int rec is going to, the sprite int rec top is going to be equal to this, depending on if we're running or if we're idle. It'll be the tile size times 5 for this. It'll be tile size times 1 is this. All right. If the left is going to be the end, meaning like if we're on idle, if we're on idle, all right, that means that we're at the very end, 0, 1, 2, 3, all right, and that's going to be essentially the tile size times 3 here, 0, 1, 2, 3, right? Then we're going to start from the start, which is the tile size times 0. We're going to start back at 0. Okay, so 0, 1, 2, 3, go back to 0, 1, 2, 3, etc. And do like a little loop like that, okay? Great. Else, if we're not greater than or equal to that, then we'll equal this. It will be incrementing by the frame size. And this is the part of the loop that actually moves. So if we're at the very beginning, we're not at the end or greater than the end. So we're going to move to this one. And we're still not greater than. So now we're at the end, so we're going to go back. And that's the way this works. And then at the very end of this, you set the sprite's texture rec to this, and then you're going to restart the clock, and the whole thing goes over again really fast until you see the entire animation. All right, fantastic. Okay, so that's it. Now, we have to do one last thing, because remember, these are all facing to the right, and we need to flip them so to the left. So you can do that using the sprite set scale function in SFML. All right, so we'll call setters. We'll call this void set scale, and we will do direction player direction in here, okay? Just like that. Okay. So if this, if player direction is equal to direction left, okay, we'll do this. And you want to do an else if here, else if right, all right? So the way that this works is essentially if you provide negative scale values, you can flip it. So in SFML, scaling is like expanding or contracting the image for actually, you know, making it bigger or smaller. But with the same function, you can still invert it. All right. So in SFML, 0 is like nothing, and 1 is the original size. So if you want to make your image smaller, you have to do like 0 point something. All right. And if you want to make it bigger, you have to do 1 point something. But if it's set to 1, then it's going to be the original size. All right. So we want to do a little check here first, because you don't want to set this all the time. You just want to set this once when you turn left and you turn right. So you're going to do if, so essentially we have to use the negative version of the X variable to flip it to the left when we want to. So we're going to do if this sprite dot get scale dot, well, that's fine, is equal to, and this sends out a vector 2f, so SF vector 2f negative 1 point f 1 point f. All right. And actually, I'm sorry, this has got to be if it doesn't, meaning that it's already that. If it's already that, then we don't want to do this. But if it's facing right, then we do. So then we'll go this sprite dot set scale to negative 1 point f 1 point f, like that. Yeah. Cool. And we just want to copy this, and we want to put this in here. And actually, it might be better to make this a switch. Make it look a little bit cleaner. Then make this a case. I think make it look a little bit cleaner if we do this. Redo all this. So like that. Got this. This right. Just take that out. Take that out. Okay, beautiful, like that. Like that. Beautiful. And then we'll have to do break right there. And do break here. You have to always break out of switch functions, remember? Not. All right, then we'll have a default throw error player invalid switch entry. Cool. So we're going to be taking the player direction, and depending on what we have, we're going to set the scale. But we're going to do a check to make sure we're already not at that scale. Oh, and this is on the right. This needs to be just +1. All right, because we have to put it back. Otherwise, it'll just stay like that. Okay. Fantastic. All right, so that's the way that is. Awesome. So that looks good. Like that. All right, so now in the user input here, before we update the velocity, we'll do this set scale, and then throw the player direction in here like that. This. And then you can just copy this and then throw this under here as well. Like that. Awesome. Okay, now that should work. Should work. So we're gonna save all. Okay, awesome. So now we're gonna go into game.h. And in game.h, we're going to create our first member variable. So this is going to be std unique pointer player. And one thing I already forgot to do was in player, we forgot to put these into the render function. So yeah, so you just want to do target dot draw this sprite rec, and then target dot draw this sprite. Okay. Awesome. Now it's 100% done. Let's go back to game state. Oh, we got to include this. Include player. Okay. Go down here and do class player. Just add that. All right, now that should show up. Perfect. All right, so at the very bottom of this, say void init player. Cool. And we'll do this player equals std make unique player, and yeah, we want this tile size, and this game details dot supported keys, just like that. That's all we want. And this is already a unsigned. Yep. Cool. All right, now in game state constructor, we just want to call that this init player. Beautiful. Like that. Okay, so now in this, we want to do void update player, and we want to pass through this for sure. And then we'll do this player update and pass DT into there, just like that. Okay. We want to call this in here. So if the game is paused, we want to do that. But else, if the game is essentially not paused, then we want to this update player. That. And we always want the mouse position, we always want the user input, right? Yeah, and then we have specifications as far as what user input here. Okay. Cool. Oh yeah, DT. Okay, fantastic. All right, awesome. And then now what we want to do is we want to render the player on top of all this stuff, right? So we want to do void render player, and we want to do a target like that. Oh. Okay, fantastic. And then it's going to go this player dot render. Nope. Render target like that, and then add a div here. So this render player, this render texture. Cool. And hopefully this works perfectly out of the bat without any headaches. Please do that. That'd be great. All right, so we're going to run this. Oops. All right, so we can move this around. There's some weird stuff going on with the thing already. So we'll essentially debug that. So yeah, I got the sprite position in here. I got the user input. Awesome. Okay, so we got the tile map. We got this. It's greater than if the tile map equals the start. And we got frame size. Oh, you know what? I think I got to initialize. Oh, I did initialize that. Times this. Okay, what's going on? All right, I just got this working. What the heck? Okay, so let's just triple check our variables here to make sure it's all nice and good. So we got, right, we got the total time at the top. It's going to be equal to the top there. Oh! All right. So, oh, no. Tile size. Now that should be right. That should be right. Okay, so let's just see. Is it doing anything? No, it's not doing anything. Okay. Update movement. Update animation. Update input. Okay, if it's not doing this, then the animation state is going to be idle. All right, and the update direction. So, okay, update animation direction is right. Player state is idle. Let me see if maybe I need this even in the idle. No. Uh-oh. Okay, so the best way to debug this, let's just see what's going on. Let's just see what's going on. So, animation state, okay. Oh gosh, all right, so we got the sprite, that set texture ref, this, yes. Sprite that int rec. Tile size times 0, tile size times 0, times 3 equals increasing that by the frame size. So if that's going to be equal to this, else sprite and rec left, okay. Okay. Update the sprite position. Sprite rec.get position. Okay. Let me just not make sure that this is something stupid messing with this. Maybe I have to go like this. I doubt it, but we'll go through the process of debugging this if I think we'll have to. Set scales. Okay, so let's do that. Okay, that didn't work. Okay, so yeah, so put that back. Put that back to that. All right. So sprite, that's that origin. Sprite, that texture. Yep. This -1. Oh, you know what? I'm so stupid. All right, so this, it's not even initializing. So this sprite int rec equals this. And then you gotta put this. So I didn't even initialize the sprite int rec. That's one thing that was dumb. All right, there we go. Ooh, I'm kind of doing the opposite of what I want to do. But there you go, it's moving. Great. All right, so yeah, that was definitely it. So we forgot to initialize the int rec. Okay, so yeah, so let's go back. I don't even think you need this in the idle thing anymore. So yeah, do that. All right, so yeah, so I'm doing kind of the opposite of what I want to do. So if you're moving, oh, all right, I got left for both of these. All right, so change this to right. All right, there you go. And bada boom, bada bing, bada boom, bada bing. And then if you stay there, it's gonna be facing the right direction. Very stable. Okay. All right. And he doesn't come to like a complete stop. He like, you know, doesn't come to a complete stop. He kind of slides based on your velocity. But yeah, there we go. Look at that. That's really cool. Okay, cool. So we'll call this a video. All right, so let me just clean this stuff up. Clean this stuff up. Oh yeah, we got SF clock now. Okay, and here, got setters, class SF clock. Cool. So the only thing we touched, I think, was the game state. So let me go ahead and just close all that down and commit stash. All right, so created player and entity classes from scratch. All right, so game state.cpp. Actually, game state.h. Yeah, it's everything else. Sorry. All right, so game state.h. So one, we added this. Two, added this. Two, that's 4 declarations, and then 3, we added this, and then 4, we added this, and then 5, we added this, and then 6, we added this. Cool. Now game state.cpp. So 1, we added this, and then 2, we added this, 2, this, and then 3, we added this, and 4, changed this to this, and then 5, added 5, we added this, and then 6, we added this to this. Okay, cool. All right, so nice. So look at that, bam. And it stays, depending on what you're doing. It's not going to freak out. It's looking very, very lovely. Hell yeah. All right, cool. So in the next video, I think we'll try to next video, I think we'll try to make him jump or something. All right. Awesome. Oh. All right, so I'll see you all in the next video. Bye-bye.